welcome to the Explainer. Today, we're going to completely flip the script on everything you thought you knew about sewage. I know. Normally, when we think about what goes down our drains, we just view it as, well, waste. Something to flush, forget, and never think about again. But stick with me, because by the end of this, you're going to see your city's wastewater not as some gross liability, but as literally one of our most critical, untapped resources. So, let's start with kind of a wild idea. What if the very wastewater we flush away every single day is actually an absolute goldmine of renewable resources? Think about it. We're facing huge global shortages when it comes to sustainable energy, right? And our agricultural sectors, they're constantly hunting for reliable, eco-friendly fertilizers to feed a population that just keeps growing. Well, what if I told you the answer to both of those massive global challenges is quite literally flowing right beneath our streets? It sounds like totally made-up science fiction, but the technology is already here to make this a reality. Now, before we dive into the really cool solutions, we gotta understand the sheer scale of the problem we're dealing with. It's actually a shocking reality that traditional wastewater treatment drains somewhere between 1 to 3% of the entire global energy output. Just let that sink in for a second. 1 to 3% of all the energy generated by humanity is used for nothing else but cleaning our dirty water. And as our cities keep growing, that number, it's only climbing. We are basically spending an absolute fortune in electricity just to throw away resources that we could be and should be harvesting. Section 1. The linear water problem. So the core issue is our current, honestly, broken linear system. It's a classic take, make, discharge setup. We extract fresh water, we treat it, use it in our homes, and then just send it off to a plant. And at that plant, we waste massive amounts of energy literally just pumping oxygen into giant tanks for what's called aerobic digestion. Did you know over 50% of a treatment plant's energy is used just to aerate sludge before throwing it out? Yeah, it's wildly inefficient. Moving on to Section 2, the circular water pivot. Fortunately, there is a massive paradigm shift happening right now in the industry. We're moving away from that old take, make, discharge model to a much more dynamic, interconnected web. In this circular framework, we use smart digital management to reduce our use upfront, reuse whatever we can, and, most importantly for us today, actually recover resources. We are literally designing waste out of the equation entirely. Which brings us to Section 3, Sewage, a hidden energy goldmine. Here's where it gets really fascinating. If we stop forcing all that oxygen into the water, we can actually unlock that energy goldmine through something called anaerobic digestion. So instead of that energy-hungry aerobic system we talked about, we use what's called an upflow anaerobic sludge blanket reactor, or USB for short. Basically, raw sewage flows upwards through a bed of sludge, where these highly specialized bacteria get to work in a totally oxygen-free environment. Because of this, the energy demands of the plant absolutely plummet. But wait, it gets even better. This process directly extracts biothermal energy in the form of biogas. That means our sewage can literally generate electricity and heat. You see, the bacteria in that reactor naturally produce a mixture of methane and carbon dioxide as they feast. We can capture this biogas and burn it to power the treatment facility itself, or, in some cases, even push it right back into the local grid. Plus, and this is a real game changer, by integrating thermal heat recovery systems and heat pumps, we can pull thermal energy directly from municipal sewage to heat urban buildings. We are taking a major energy consumer and flipping it into a green energy producer. How cool is that? All right, Section 4, harvesting fertilizer from wastewater. So energy is really only half the story here. We can also mine our wastewater for absolutely critical agricultural nutrients, specifically nitrogen and phosphorus. And honestly, we have to get them out. Because if we just discharge these nutrients into the wild, we cause a highly destructive process called eutrophication. This creates actual aquatic dead zones. When too much nitrogen and phosphorus enter our rivers and lakes, it triggers these massive, abnormal blooms of algae. And when that algae eventually dies, the decomposition process sucks all the oxygen right out of the water, which suffocates fish and totally wrecks the ecosystem. Now, the incredible irony of all this is that the exact same nutrients destroying our rivers are the exact fertilizers we so desperately need for agriculture. It's wild. On one hand, we are spending billions globally to mine phosphorus and synthesize nitrogen just to put it on our crops. But then, on the other hand, we spend billions trying to scrub those exact same elements out of our municipal wastewater to stop them from destroying our natural waterways. Talk about a massive disconnect, right? But by catching these nutrients at the treatment plant through a step-by-step biological and chemical recovery process, we solve pollution and resource shortages simultaneously. It's a two birds, one stone situation. Through processes like nitrification, denitrification, and chemical precipitation, we can safely pull these elements out. We can literally precipitate out highly valuable phosphorus, very often in a form known as struvite, and capture that nitrogen. We're taking a dangerous pollutant and turning it into a premium, completely sustainable fertilizer. From there, farmers can apply these recovered, sustainable fertilizers following what's known as the 4Rs principles to hit both their economic and environmental goals. This stewardship initiative ensures that we're using the right nutrient source, applying it at the right rate, at the right time, and in the right place. By closing the loop locally, a city's wastewater can literally fertilize the very farms that feed that city. This dramatically reduces the massive carbon footprint associated with mining and shipping traditional commercial fertilizers all the way across the globe. Okay, Section 5, the Resource Recovery Factory. This all really culminates in a grand vision for our urban infrastructure. We absolutely must stop viewing these facilities as mere disposal sites and start treating them as water refineries and resource factories. The technology is already here, today, to deploy advanced membrane bioreactors, anaerobic digesters, and those nutrient recovery systems we just talked about. What we need right now is a shift in mindset. We need to fully embrace this circular economy. Our wastewater plants shouldn't just be out of sight, out of mind. They should be the beating heart of local sustainability, producing clean water, green electricity, biothermal heat, and rich fertilizers, all at the exact same time. So I'm going to leave you with this final thought to chew on. Is your city managing its water simply as waste, or are they mining it for the future? The next time you turn on the tap or flush the drain, just remember those hidden treasures flowing right beneath our streets. We just need to be smart enough to catch them. Thanks so much for joining me on this explainer. Keep learning, and I'll see you next time.